We'll proceed in pseudo calculus problems. Okay, so in addition to solving the mathematical problem, probably through calculus, not required, we have taken example where we did not use calculus at all. Simple with the algebra and vector, we solved the problem. We did not use calculus at all. Calculus is used where there is division and there is multiplication. Division of two algebra where the north is dependent upon south. I mean, the numerator is dependent upon denominator, and multiplication means where west is dependent upon east, means where the where the two operand of multiplication operator, they are dependent upon each other. Then also we use, in multiplication will be replaced by integral calculus, and division will be replaced by division with the differential calculus. So this is what we have seen. Then we saw that repeated addition also contributes to calculus, integral calculus. People would so say that repeated addition generally it comes under multiplication arena. Okay, multiplication comes under integral calculus arena. Anyway, before we proceed into repeated addition fundamental, then we saw digital and analog signal. What is digital signal and what is analog signal? If someone is adding the amplitude of digital signal, I have antenna here. Hope I received a digital signal. What is the magnitude of this signal? Hope I received a digital signal. What is the magnitude of digital signal? Hope I received a digital signal. What is the magnitude of this digital signal? If I add all these digital signal and where the digital signal are infinite in number, can we use integral instead of repeated addition? That is under question mark. Please watch our previous video where we have talked in detail that where a digital entity can be replaced with the integral calculus. Anyways, now consider where. Okay, what I can say. Okay, just consider this is iron rod. May not look like iron, it is wooden, but consider this is iron rod. This is what is integration. Integration is calculation of multiplication through graphical way, and calculating the area is integration. What is multiplication and what is area? Multiplication of two items. Actually, this can be seen one item multiplication another item. These two items can be seen as two sides of 2D shape. 2D shape has two sides. Wow, 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 wow. I have a circle. Now show me where is two sides. Abstract sides. What is the basic 2D shape? Basic 2D shape is rectangle. That is the basic 2D shape. And it has width and height. What about circle? Now someone can think width and height there also. Any 2D shape has two sides, and these two sides, any two sides constitute a 2D shape. Whatever area is formed in these two sides, if I am able to calculate the area, that area is exactly same as multiplication of these two items. What are you trying to say? If I draw a graph with two sides, one is I have A into B. If I am drawing a graph where one side is A and one side is B, and then I draw the 2D shape with the one side as A and one side as B, and then I draw a 2D shape. And if I calculate area of that 2D shape, it will give me A into B. Certainly, not only it will give A into B, it will give much bigger than A into B. Perfect A into B. This is what I am saying. Perfect A into B. What do you mean by perfect and imperfect A into B? Because consider A into B. B is X and A is sine X. B is X and A is sine X. Multiplication of sine X into X will be X sine X. But that is not true always. If they are independent to each other, then it will be multiplication. Otherwise, if this is X axis and sine X graph is like this, Makes sense? This is origin, and sin x graph is like this. This proves that as we move along x-axis, sin x means a into b. A is height and b is along this direction. Sin x means as we move along x-axis, height is changing. Means height is in variation with the movement in x-axis. Means a is dependent upon b. A into b. A is sin x into x, where sin x and x are tied to each other. In that fashion, sin x into x will not be x sin x. It will be the area. Okay, because multiplication means area. Integral calculus says area is actual multiplication. Makes sense? If people say that if I'm able to calculate multiplication through area also, if I say 3 into 2, I can make 3, 2 and 3. It will make a rectangle. If I find area of this rectangle through any mean, not through multiplication, any mean, that is same as 3 into 2. In 3 into 2 multiplication can be computed in a graphical way, where you have to make the area and calculate the area, and the area is the multiplication. Integral calculus is saying area is actual multiplication. Otherwise, I believe it is all right. Means area is a form of multiplication. This is what normal multiplication says. Integral calculus says multiplication is form of area. Area is mean. Area is mean. It focus on area. Anyway, now I have an iron rod. An iron rod has D density. Iron rod has density that is different. What is density? Density is weight per unit length. This is the density right now. Means if I take here this length is x. This length is x centimeter. What is density? Density is d kilogram per unit centimeter. Makes sense? Okay, what is density of your rod? Rod has density as d kilogram per unit centimeter. What is the weight of this? Provided the length is x centimeter, d into x is the weight of this line. This this iron rod weight is d into length, that is x. Okay, that is the weight. What about density is not fixed d. Density varies with the x. At the origin, there is no density at all, or density equal to 1 plus x. If x is 0, the density is 1. When x is 1, the density is 2. X is x is 10, the density is 11 kilogram per centimeter. Means at this point, if this distance is 10 from this origin, at this point density is 10 kilogram per unit centimeter. If this length is x, if length is x, tell me the weight of this rod. Make sense? Okay. Oh, I cannot use integral calculus because integral calculus talks about area. If this is x-axis, then this is y-axis. And y-axis is the height, and height is changing as we go along the x-axis. Then if I do height is considered y dx, y into x is the area. If y is changing with the x, then y into x will convert into dx, y into dx. X is from one limit to another limit, what we are calculating. If it is 0 to d, 0 to l, any l, 0 to l, I'm trying to calculate y into x, where x is of length l from origin. Then instead of saying y into l, I'll say y dx, and dx is from 0 to l. Thank you very much. But I do not have any height as such. I have density. This iron rod density from origin, density is changing. Okay, and it is 1 plus x. Density can be sin x, mod sin x. Sin x means it has negative also. Density cannot be negative. Density is not a vector quantity. So I can say absolute of sin x. Absolute of sin x means here density is 0. Density cannot be 0, then 1 plus sin x, someone can say. 1 plus sin x. Here density is 1. When x is pi by 2, then it is 2. When x is pi, it is again 1. Now, when x is more than pi, it should be negative, but we have talked about that kind of absolute value of sin x. Then again, it will start, density will start growing. When it is 3 pi by 2, density is 2. And when it is 2 pi, density is 1. Means density is growing, density is reducing, density is growing, density is reducing, density is growing. From 0 to any x, I want in term of x only. What is the weight of this rod? Makes sense? Okay. Now consider this density. Consider this density is height. Consider. So when I'm saying y equal to 1 plus sin x, when x equal to 0, height is 1. When x equal to pi by 2, height is 1 by 2. When x equal to pi, height is 1. Like that. Magnitude of sin x. Okay. Now in that fashion, what is the area? What is the area? If I take plus and minus both, then they will nullify each other. But here, everything will come as positive only. Someone can try, but I don't know how. What is the integration of absolute? So let's try only 0 to pi only. Then we will double it. It makes sense. The weight we will do because they are congruent now. 0 to pi. Now, I'm not saying that you go and calculate the weight. I'm saying you calculate the area only. Who is stopping you? Consider the density as height. Density is height because internally I know density into length is the weight. Density means kilogram per centimeter. Into length will give the kilogram only. Either you consider height. So height is not a physical entity. This is what I'm trying to say. Integration can be used for the density also. Considering density as the height, then it will become 1 plus sine x dx. Okay, and where x is 0 to pi, it will become x plus x minus x cos x. I'm sorry, x minus cos x, because integration of sin x is minus cos x. So it will become integration of 1 will become x minus cos x, 0 to pi, means pi plus cos pi is minus 1. So x minus cos x minus 1, minus 1 cos pi is minus 1, 2. 1, it will become pi plus 1. Then if I set up 0, then it will become 0, and another 1 will become minus minus plus again, I believe. Then it will become 1 again. It will become pi plus 2. This is what I think. Pi plus 2. So pi plus 2 is the weight of this rod. Pi plus 2 kilogram. Pi, it is not a very numerical number. Pi plus 2 is the weight of, means we can use anyway. I believe it is all right. People can understand now that integral calculus is a way to calculate multiplication when where one operand in multiplication is x-axis and another operand in multiplication is y-axis. Y-axis may not be height only; it can be density or whatsoever. Anyway, okay, so we are going through mind-blowing discussion of repeated addition can also make integral calculus, because repeated addition internally it is multiplication only. What is repeated addition? You are keep on telling repeated addition, repeated addition. What is repeated addition? Okay, repeat this here also there was repeated addition. Repeated addition. If I want to calculate weight of this rod, then density means kilogram per centimeter. Okay, now I have kilogram per centimeter is 1 plus sin x. 1 plus sin x is the kilogram per centimeter, where x is what x you are taking at that moment. So if I say I have a density 1 plus sin x, then what is the weight for the first centimeter? What is the weight for second centimeter? What is the weight for third centimeter? 1 centimeter, 1 centimeter I am taking. What is the weight for first centimeter? The weight for first centimeter is 1 plus sin x, 1 plus sin x, that is the density, into distance will give the weight. 1 plus sin x, consider the x I am taking midway. Midway means at 0.5, or I can take at the beginning also. 1 plus sine 0 into 1, that will give the weight for the first centimeter. Second centimeter, 1 plus sine x, x equal to 1. So 1 plus sine 1 into 1, because I want for 1 centimeter. So it becomes now 1 1 plus sine x. This is a density function we are taking. 1 plus sine x in bracket at x equal to 0 into 1. Okay. Plus 1 plus sine x bracket close x equal to 1 into 1. Now we keep adding like this. Now it will become like 1 plus sine x, 1 plus sine x. If I see the summation I equal to 0 to I equal to n, or if I say first section, second section, third section rather than 0, 1, 2, 3, then I equal to 1 to I equal to n. 1 plus sine x, x at x equal to I, ith section of the thing, into xi. Xi is the distance that I have taken fixed 1 centimeter. I may not take fixed 1 centimeter. I may take first, first I may take as xi as different centimeter. Makes sense? Consider that when I am calculating it, this first I am taking as x1 centimeter. X, x, bottom, right, xi. I divide this into, I'm trying to calculate the weight of this rod from 0 to pi. 0 to pi. This is where I'm trying to calculate the weight. 0 to pi, I divided it into n section, where n tends to infinity. Okay, anyway, I divided it into n section. What is the weight of first section? I equal to 1. The weight of first section is 1 plus sine x. In first section, I take x at any location. Okay, between 0 to whatever the value comes. If I divide 0 to pi into 10 part, then 0 to pi by 10, then pi by 10 to 2 pi by 10, then 2 pi by 10 to 3 pi by 10. If I am dividing it in equal part, consider I am not dividing it into equal part. First part has a length called x1. Second part has length x2. Third part has length x3. So that x1 plus x2 plus x3 plus xn equal to pi. Makes sense? Now what is the weight of this rod? Okay. Now I am not calculating through area weight. Earlier I calculated through area weight. I consider height as density of the rod at any moment. And then calculating the area gave me the weight. People are not satisfied. They want through villager way. There is something called village way in India, where you don't imagine anything. This is the height and then, no, don't require. Don't imagine anything. You want 0 to pi, right? Then divide 0 to pi into n part. Each part calculate the weight and add it. Makes sense? Now the first part is second part, third part, fourth part, fifth part, nth part, where n tends to infinity. That much I divided 0 to pi. Now first part, what is the weight? First part, now if I say this is the part, from here to here this is the one part. First part means x equal to 0 to x equal to pi by n. Pi by n. Now I take x 1 plus sine x when x equal to 0, and I multiply it by this distance, that is xi. Okay, that is x1. Then I come here. Now this is another part. Here x equal to x I have taken as pi by n, pi by n into 1. So here it is 0, here pi by n to 2 pi by n. Now here I calculated 1 plus sine x multiplied by this distance, that is x2. Similarly, I kept doing like that. It will become a summation. Summation I equal to 1 to n. I equal to 1 to n. Summation. Now here it will become density, that is 1 plus sine x, sine x, sine xi. 1 plus sine xi in the ith part into xi. Okay, 1 plus sine x, bracket close xi. If I keep adding like this, it becomes 1 plus sine x1 bracket close into x1 plus 1 plus sine x2 bracket close into x2 plus 1 plus sine x3 bracket close into x3, where 1 to 3 are the part. This will become like this. At the end, it will become 1 plus sine xn, x bottom right n bracket close into xn, where x1 plus x2 plus x3 plus x4 plus xn equal to pi. This is more or less repeated addition. This is not exact repeated addition. What is exact repeated addition? Exact repeated addition means 5 into x. If I want 5 into x, then 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus x time. Or rather, I say 5 into n. 5 into n is same as repeating 5 as addition. 5 plus 5 plus 5 plus 5 n times, that is 5 into n. So 5 into n, this is called repeated addition. Multiplication can be achieved through repeated addition. Loosely, this is repeated addition, where it is 1 plus sine x1 bracket close x1 plus 1 plus sine x2 bracket close into x2 plus 1 plus sine x3 bracket close into x3 plus 1 plus sine xn bracket close into xn. Okay, in that fashion, this is a repeated addition. More loosely, I can write it as or loosely what? In a straightforward, I can write is a summation I equal to 1 to n 1 plus sine xi bracket close into xi. When xi, if I keep adding x all xi, it becomes pi. This is what we want, that become x-axis. It will become x-axis. In this case, this can be replaced with 1 plus sine x bracket close dx. The xi that is so small, I can write as delta xi. Delta xi. Mind it that all xi are not same. That is the difference. All xi are not same. Still, addition of all xi gives the x-axis. X-axis is divided into many parts where each part is not equal, but addition of all part give the full length. Now this can be this whatever we are talking now can be replaced with, that is sigma, that is the addition summation. I believe this is the summation sign. Up. Okay, that is gone. Okay, this is summation sign. This line, this line, and then this line, and this line. This is summation sign. This line, and then this line. This is, I don't know, it is called sigma or something. I don't know. This is summation line. This, 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 this. This is summation. So summation and bottom I equal to 1, on top of summation I equal to n. I equal to 1 to n, and then fx function over x, fxi into xi, f bracket x and bottom right is I, xi, f xi bracket close into xi. If that is the condition, the last xi can be rewritten as delta xi, because it is very small. Delta xi. Write delta or don't write delta. It is all right. But if n tends to infinity, that is the biggest thing. N tends to infinity. N tends to infinity. If that is the case, then it can be written as fx dx. Makes sense? This is another idea where we can use integration. Can I write summation I equal to 1 to n fxi? There is no multiplied by xi. Just fxi. Summation I equal to 1 to n fxi equal to fx dx? Certainly. You can write, provided that I equal to 1 to n, everywhere the gap is 1 unit. then you can provide. There is no point one gap, point two gap, point three gap. No, 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 there is a point. Okay, I am receiving, this is my antenna. Antenna up, I received a signal. What is the strength of the signal? Strength of the signal is 2. Sum 2. 2. Hop. I received a signal. Hop, 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 hop. I keep on receiving the signal. Signal is consider the signal is dependent upon is a function of something. Signal is function over something. What is function over something? Signal is function over time. Some function is there over time. It can be t. T means as you grow in time, signal strength will grow. Or it is sinusoidal. It will grow, it will come back, and then signal will come in the reverse polarity. Okay, that is sinusoidal way. It can come, but it is a function of time. How it will grow and how it will shrink and how it will reverse, that is depend upon time. Okay, now I keep on receiving signal and then I put in a timeline. When I receive signal at what time? Okay, consider the signal is ft, function over t. Then I keep adding all the signal. At this time, this is the signal. At this time, this is the signal. At this time, this is the signal. Now, what is the net signal I received? Summation I equal to 1 to n f t n at time 1, time 2, time 3. Can this be replaced with the integral calculus ft dt? No. No. Why it cannot be replaced with the FTDT? There is no guarantee that the time gap what we are writing on the paper is 1 second. If it is 1 second, every 1 second I am placing the data, then it can be replaced. Because at the end you have to come in rectangle fundamental. Please watch our previous video or previous to previous video. Okay, then when it can be written integral? If gap is 1 second, or you discard everything if it is not, if it is falling in between every 1 second. No, 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 that is required. One, if first signal is received at time equal to 0, then I note down the amplitude. Second signal is received at time equal to 0.025, zero 0.25 second. Then I note down. Second is received at zero point 0.3, then I note down. Third is received at t equal to 4 after gap, then I note down. Then how I can do integral calculus. Okay, you can use integral calculus in a fashion that it will come as ft 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 delta t. What is the height of the what is the strength of the signal, and then multiplied by the duration. So first duration is 0.25, second duration is 0.05, third duration is this. If this kind of scenario is there, I don't know in practicality and reality, if you are happy to multiply height by the distance, if you don't multiply height by distance, the distance on x-axis, it will be considered as 1 second. If that is all right, then it can be converted into integral calculus. Otherwise, it will be repeated addition where height and gap, the gap has to be mentioned explicitly. Then see, it can be calculated in integral calculus or not. Anyway, okay, I have another example. Okay, what example you carry? I have another example. What is the length of this perimeter? Earlier we talked about the area. There something is lagging, we will cover it. But we have covered full, we have given the full sense. Only thing I have to prove that area is dp by d theta cross dp by dr into d theta dr. That we have proved many times. That area of the circle, if I, this is x-axis, this is x-axis, and this is y-axis. In that fashion, if there is any point P here, then from origin I can draw a line. This point P is x comma y. From origin, I can draw a line that vector is called position vector of this point. Makes sense? This is a circle, and on the circle I have any point P here. From origin, I draw a line like this, and this point P is x comma y. The line equation will be that this is called also position vector will be xi plus yj. Okay, If I say dp by d theta, p is xi plus yj. dp by d theta cross product, because that will come as vector only. The differentiation of position vector, any vector will bring the another vector. So dp by d theta, where this is in xy plane, consider that x is a function of r theta and y is function of r theta, then it will make another plane called r theta plane. Or I can adjust x, y and r theta in same plane, where x equal to function over r theta and y equal to function over r theta, x equal to r cos theta, y equal to r sin theta, where r is function over theta. If y is function over x and it draw a circle, then we will have another coordinate system, that is r theta, called polar coordinate system, where r is function over theta. It can be, not necessarily, but it can be. R is function over theta. Okay, in that fashion, I have a point here, P, and in Cartesian coordinate, I can write it as a P position vector. P equal to xi plus yj. dp by d theta, where x is function over r and theta. dp by dr, where y is function over r theta, into d theta dr, will give the area vector of the shape. Calculating the magnitude of the area vector will give the area, and that comes as exactly r dr d theta. R d theta is anywhere there. dp by d theta cross dp by dr, where p is xi plus yj, then it will become as r only. This is also called, typically called Jacobian r. It will become r dr d theta. It will become r square by 2 d theta. R square by 2 d theta, this is what we talked about. If I make it in different triangles, I can cut this circle into wedges. I can cut this circle into wedges. One wedge is like this. This is one wedge. Okay, so this is one wedge, like this. So this is a from the center of the circle. From the center of the circle, I take one radius, and center of the circle I take another radius. Okay, and then this wedge shape, what we see arc, and in between this area, this is called one section. Like that, I divide this circle full into so many wedges, n wedges, where n tends to infinity. If I know area of one wedge, then if I keep adding all n, it gives the area of this circle. Okay, okay. Area of the circle is not the only thing that is difficult in the circle. Okay, what is the length of this parameter? Okay, that is impossible to calculate. Okay, I know what is length of the circle. I can just open it. I can I can really open it. Now calculate the length. Boss, thank you very much. Okay, if I draw a line on the ground, or draw a line on the paper, then how you can unfold it? Not possible. Okay, in that sense, what is the perimeter of a circle? That is the question mark. Understood, understood, understood. Okay, then you have to take this dy by dx, that or simple person will not understand your dy by dx. What he will do? He will do, now he will take one section like this, one small section, one small arc section here, and he will calculate, he will divide this full arc into n part, probably in 8 part, or in 20 or 24 part, or something like that. 8 part, 16 part, let's take in binary, 8 part, 16 part, 32 part, 64 part, whatever it is. He divide into many sections. Each one section length he will calculate very meticulously. He divide, probably he will draw a line like this and line like this. Now it is divided into 4 parts. Make sense? It divided into 4 parts now. Now take one part, take any one part, take any one part and divide into 3. Then more or less divide into 4 again. Do something compass, divide into 4. More or less it becomes 16 parts. Now for that one part, calculate the arc length. Meticulously calculate the arc length. Multiply by 16. You will get the length of the arc of the circle. Thank you very much. How to calculate the length of this R circle while dividing it into n parts, and then calculating length of one part and multiplying it by n. Okay, then where is calculus? I can measure it. Measure it. Where I'm saying we need calculus. Try. Okay, I believe it is all right that someone can try. So I believe it is all right, and someone can try and find out. Okay, so this is called integration, where we need repeated addition. Arc length one arc length, and then repeatedly add it for the full arc. It will give you the net arc length. If repeated addition comes into the picture, then can we replace with the integral calculus? That is the question mark. In what scenario? But this scenario looks promising that we have repeated addition. Now question is arising, what is the length of this arc? Okay, I know this length of this arc. I know this length of this arc. If it makes theta angle, if it makes theta angle, consider it makes this arc I am taking up. The arc I am taking, it is making theta angle from the center. So if I'm taking this arc and this is theta angle, then this arc is radius into theta. Now I know theta angle, delta theta. So one arc is r into delta theta. Okay, so if I divide into n sections, then it is summation of I equal to 1 to n r theta, r theta I. If r is function over theta, consider r is function over theta, then f theta I into theta I, summation of I equal to 1 to n. Another person is saying, no, not required that way. Why you are doing that way? Okay, consider this is x-axis, and this is what consider it is. This is x-axis and this is y-axis. Okay, this is x-axis and this is y-axis. This is origin. Now take any point x here and any point y here. It will come here. Make sense? Now from x move delta x, and if I move x from, now I take any point x here, it go hits here, and that height is y. Now I move delta x here, again it go and hit a point here, that is another point. This is x comma y, then this point is x plus delta x comma y plus, consider the change in the height is delta y plus delta y. Now I have 2 points. One is x plus delta x, one is y plus, I'm sorry, one is x comma y. This is x comma y. And this is x plus delta x comma y plus delta y. What is this length? If I consider this, if this length is very small, then it will behave like a tangent line. Make sense? If it is length, these 2 points are at large distance, then it will behave like a circular arc. But if these 2 points are very small distanced, then it will show as a small tangent line. If this is a tangent line, then what is the length of tangent line? That is make a hypotenuse. That is delta x delta y, and hypotenuse, that is delta x square plus delta y square. The square root is this length. That is for section 1 I, any section I. I have divided now into n part. That is also true. That is also true. That is I plus I equal to summation I equal to 1 to n, where n tends to infinity. Square root delta x ith section whole square plus delta y ith section whole square. That is length of this arc, this arc at this point. Sum it, you will get the full perimeter. Please do not mind supporting us. We will do in many ways, not in one way, many ways. They do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone.